Welcome to the video demo of catalog scoring mechanism. Today we will dive into the world of catalog scoring and explore how Team CodeGeeks has implemented a scoring mechanism using a support vector regression model (SVM). So basically, first of all, what is a catalog scoring mechanism? The catalog scoring mechanism involves defining a set of granular assessment parameters along with their respective weights. The parameters can be categorized into compliance, correctness, and completeness. We'll adjust weights based on the criticality of compliance in specific industry or region. Like in correctness, we'll give brand authenticity, and in compliance, we can give labeling regulations. In completeness, we can give image availability, pricing information, product descriptions, etc. We can use various machine learning models to solve this or to implement this catalog scoring mechanism, but we are using support vector regression model to implement this. So first of all, we need to import two main libraries, that is pandas and numpy. Pandas is used for data manipulation and analysis, and numpy is for provides support for multidimensional and large arrays for matrices, and we have mathematical functions to operate them. First of all, we need to have a data set. There is no data set, like we can create a synthetic data set for example a 2000 items. Okay, so we'll generate a seed value of 42. Generally seed is set for the reproducibility of random numbers, like we can generate same seed value to get the same random numbers. Okay, so we took 8 parameters for this, for the 3 factors, completeness and compliance and correctness. Those 3 parameters are those 3 factors are considered for 8 parameters. So first of all, we took labeling compliance, display compliance, branding compliance, brand authenticity, info accuracy, image availability, pricing info, and descriptions. So we are taking the values from 0 to 1, any random value, and we are generating a 2000 rows. We are generating 2000 rows of data. So we are storing it in a data frame. Now we are giving certain weights to each data, because weights define the criticality of the parameter. So it indicates their importance. Here we gave labeling compliance 0.1, display compliance 0.15, branding compliance 0.15, wait a second, and brand authenticity 0.2, info accuracy 0.1, image availability 0.2, pricing info 0.15, and descriptions 0.1. So basically here we gave certain values, like certain scores for each parameter. Image availability and brand authenticity have more values, more score. That indicates it has most priority or most importance. Think of it in a real life. We buy the product or we select the product based on the image. So we gave more importance or more score to image availability. And next, brand authenticity is given them another score, same score as image availability, because brand authenticity is seen everywhere, like duplicate products can be uh, sold outside. So these are the weights given to each parameter. Now what are we doing? We are selecting the columns based on the keys of the weights dictionaries, and we are multiplying by 100 to get score of each product. See, each product score will get. So we are storing it in a CSV file, catalog dataset. So we are now getting a synthetic dataset, like uh, random dataset for use that can be used in daily life. So basically we have generated this data frame. See, labeling complaints, display complaints, branding complaints, brand authenticity, info accuracy, image availability, pricing info, descriptions, and and score. See, scores are varies from 0 to 100, most probably 50s, 50s to 60s. We can see mostly scores are from 60 to 70. We have generated total of 2000 rows. So first of all, we have the data set that has the 8 parameters and their scores. We need to train this data, right? So our next method is importing the SVM model, support vector regression model. So we import scikit-learn model selection, train test split, standard scalar, SVR, mean squared error, R2 score. These are metrics we'll learn soon. So first of all, what is support vector regression? Basically, support vector regression is a model. It is a machine learning model. It trains the data and we'll get the testing data. So mean square error, difference between actual and predicted values, average square, difference between actual and predicted values, and R2 score is a R squared score indicating the proportion of variance in the dependent variable that's predicted from independent variable. Okay, so we'll see how it works and all. First of all, let's give the target variable as y. We give target variable as y because we need to predict the score for future data, and x we are giving remaining columns, means except score remaining rows are given to, remaining columns are given to x, means x is a two-dimensional and y is a single dimensional. X has independent variables and y is a dependent variable which is dependent on x. Now we'll take x train, y x test, y train and y test. Train test split xy. We have taken test as 0.2, means we are giving testing of 20% and training of 80%. That means training is 80% and we'll test on the data 20%. Random state is nothing but it's random seed for reproducibility, like we can again generate it, that's all. Okay, that means 80% training and 20% testing. So we are now the next concept is standardizing features. Like it standardizing means it is a standard scalar object, means scaling is important because sometimes features can be uh, like there is a noisy data in that. So we compute the mean and standard deviation from the training set and standardize the features. Okay, see, scalar.transform applies the same transformation to the testing set. See, this is applied on training set, scalar.fit transform, and scalar.transform is applied on training testing set. Okay, so this uses mean and deviation. Okay, now we are building the model. So initializes SVR model is we are taking kernel as linear kernel and we are initializing the SVR model, that is support vector regression model, and we are fitting the train data into the model, exchange scale and y train. So the model has been created. Now we should evaluate the model on the test set. So it generates predictions on the scale test set, right? That's all. So we have got the testing data and training data and predictions are done. So we are evaluating the metrics now. The mean squared error. It's the mean squared error between the actual and predicted values, right? We got it as 0.0016. That's pretty good. As it is tending to 0, it's good value. And R2 score is, wait a second, R2 score is 0.999. That is pretty good. R2 score should be nearer to 1. That means the model is very good. So coming to columns. So we need to test on and predict on the random data set. So we are generating the new synthetic data set on 100 random items, and we are doing the scalar transform features, and we are predicting the scores of the random generated data. So we got these scores here. These are predicted scores. We have trained the model and we are testing on the random data set. So exactly, we are getting between 70 to like nearly 40s, 50s, 70s, 100. This is 83. This means this product is good. Score 11. So this is overall catalog scoring mechanism we have worked on using support vector regression. So we are getting accurate score, may not be accurate, but this course helps to identify the best catalog and based on the score of the catalog, so that we can get genuine products on them. So this is how our catalog scoring mechanism works, and we can use any other models like neural networks or uh, like linear regression, logistic regression, or we can use something like direct predictions. May not be predictions, but we can train the data using recurrent neural networks and all. So this is how our model works, and we got predicted data. So this model can be implemented in real life. We did not develop website like web model using Django or Flask because of less time. So this model can be integrated to the web design, and we can get catalogs. We can add any more parameters here, like which parameters you need, you can add here. We took 8 parameters so that we get we can give required weights here. So that's all. Thank you for watching. Thank you. We are hoping that our model works out and build for Bharat. Thank you.